This conference will now be recorded.
Today we'll be talking about a version control system. Okay, like in yesterday's class, we have an introduction to what is DevOps, why DevOps, what is a CI/CD pipeline. We got the big picture about the course, right? We have understood the agenda of the course. So today we are getting started with the first tool in our course, which is a version control system. So we'll be learning about what is a version control system, why do we need it, what are the different types of version control systems, the architecture of version control system, then why we are going with Git, what is Git, and then Git architecture, and then we'll start with the hands-on on Git, right? So let's start. So yeah, what is a version control system? Some of you might be aware of it. Yeah, let me tell you in simple. Version control system help you to manage your files. Managing your files means, what is meant by managing? Maintaining versions of your files, maintaining backup of your files. Okay, it maintains a log of the changes happening to the files. It also allows people to work parallelly, right? All this can be done through version control system. Let me put it in more detail. To understand the importance of version control system, let's take a simple example. Here I am explaining a scenario where version control system is not used. Okay, without version control system, this would be the use case. Let's say there's a project. Okay, some remote work is happening here. Let's say there is some file 1, file 2, and so on. Okay, we are making some changes to these files. In a project, you might be having a lot of program files or else some configuration files, whatever it is. These files are static files. They might be any programming files for developers or else like testers, any test scripts. If you talk about ops teams, there might be some configuration files, whatever it is. So some project work or else the program files or the project files are kept on some remote location. This is a remote server and it is shared across multiple people. Let's say there is a DevOps person or tester or developer, you may consider anyone, because version control system is used by everyone. So let's take a DevOps person A, he has to work on file 1. Similarly, another DevOps person B, he also has to work on the same file, file 1. So A got this file or A downloaded this file to his local computer. Similarly, B also downloaded this file to his local, B also downloaded the same file, not file 2, the same file. Okay, file 1 to his local computer. So both of them made some changes, and let's say this person A kept this file back on day 1, or else let's say he kept this file back. Okay, after making changes, he kept this file back to the remote location on day 1, let's say on Monday. Developer B or DevOps person B also made some changes and he put the same file back on day 2. So now the file 1 on this remote location finally will have which person changes, whether it have person A changes or person B changes. I'm talking about a scenario without version control system. So finally this file will have which person changes. This is a simple logic. Here we are not using any version control system. Finally, this file will have which person changes.
Later subject B.
Later changes means only person B changes, because what is happening here? Person A changes are overwritten by person B changes, correct? Person B is overwriting person A changes. So means what is happening, like this is happening without knowing, because B doesn't know that he is overwriting his changes. Similarly, A doesn't know that his changes are being overwritten, right? This doesn't they doesn't know this is happening at the back end. So if this keep on going, let's imagine there's a team of developers or team of DevOps people, a team of 10 people. If this keep on going, at some point project could be messed up, isn't it, or corrupted, isn't it? So how to avoid this problem means we need a system which can allow multiple people to work on the same file at the same time. File 1 is there might be say different people working on the same file. Okay, they cannot, their task is to just make some modifications and keep it. They cannot just go back and keep on tracking the file, keep on maintaining security for the file. They cannot keep on watching this file, right? So there comes a system like version control systems. If you use here, this is the scenario without version control system. But if you use version control system, this will not happen. Means version control system allow people to work simultaneously on the same file, on the same code base. Right? Means it allows proper collaboration within the team. Right? That's what version control system does. So what else version control system does? Let's talk about another scenario. Let's suppose, okay, there is some huge code base or else configuration files here. Okay, till 7 a.m. application is doing good. It was all fine. At 7:30, suddenly application got crashed. Okay, there is some impact on the business. Immediately, the changes should be removed. But how do you know what happened in between? Right? Let's say multiple people are keep on going to making changes, and yeah, there's no tracking. How is that possible? Isn't it? So again, there is a version control system which helps us in maintaining a detailed logging. Means that it creates or it maintains a log in such way that, okay, at 7:10 change was made on file 1 by person A on line number 4. Right, this kind of detailed logging, including the timestamp, including the person who made the change, the file, the lines. Okay, this kind of logging will be maintained by a version control system. So you can easily identify the log between this time, and you can identify what went wrong, and easily you can revert or remove those changes and bring the system back, right, without impacting the business. So again, this kind of logging we cannot manage manually, isn't it? So that's another advantage. Also, it helps you in maintaining backups, versions. Let's suppose we are having a file 1, it's a version 1, we are making some changes. Suppose client want to make some other version of this file by adding some changes, which is version 2. Okay, I have edited or modified the same file and made version 2. Okay, so there is no more version 1 now, only version 2 is there. But client after 6 months came back and said they just want the old version. Isn't it? Sometimes if new version is not doing well, they may revert back to the older versions, revert to the older versions. But I have deleted version V1 and made version V2, or else I have edited the same. Don't ever do that. Maintain the versions, maintain the backups. Okay, you maintain v1 version of file 1. Similarly, you maintain version 2, I mean version 2 of file 1. So maintain the backups, maintain the versions, all of them will be taken care by version control system, right? These are the main things what a version control system can do. Backup the files, maintain the store the files securely, maintain the logging, allow multiple people to work on the files. So this is what a version control system does. And yes, definitely, who uses this, isn't it? Yes, developers need this version control system. QA team need this version control system. Devops team uses this version control system. Particularly, whoever in IT should learn this version control systems definitely. Right? How, why developers need it? Yes, developers will use this version control system to manage their code base, right? Their files, their static files, all these are called program files, whatever. The files, these files may be written in any language, C Sharp, Java, Perl, Beach, whatever it is. Or else if you talk about QA people, they may be automation test scripts. If you talk about DevOps person, they might be some configuration files, some Kubernetes configuration files, Terraform configuration files and all. Whatever be the file, okay, how do you manage your program, how do you manage your project is same. So everyone should know version control system, but generally it's a life of developers, because developers definitely mandatorily need it. But nowadays, yes, everyone need this version control system. So we were talking about version control system now from the point of managing your project work, managing your code base. Okay, once we learn this, we'll also learn to implement or to integrate this in the CI/CD pipeline. First, we'll learn from perspective of managing our files. Then we'll learn about from the perspective of CI/CD. Am I making sense? So learn Git thoroughly. I mean, learn any version control system thoroughly. because that's how you manage your files. If you don't know version control system, but you have learned Terraform, Kubernetes very well, you mastered them, okay, you have created some Terraform config file. How do you store that? How do you maintain the versions of it? Isn't it? You should take help from someone else to place your Terraform config files or maintain their versions and all. So definitely everyone should learn this version control system. Any questions on this part? A quick confirmation will help me. Any questions? If something is not clear or if it is clear, appreciate your quick responses. Just let me know. Any questions, confusions, or is it clear?
It is clear.
So this is what a version control system does, and based on the architecture, version control systems were categorized actually. Based on the architecture, they were categorized as centralized version control systems and distributed version control systems. Okay, how are they categorized? What are those? Let's see. So centralized version control systems and distributed version control system. See here, there is a remote repository. Okay, first let's talk about centralized version control system. Okay, this is means based on the architecture they were categorized. So this is the architecture of centralized version control system. See, there is a central server or a remote server, whatever you call it. Yeah, this one. Okay, this is called central server or remote server. Here all the project work, all the files were kept here, and here you are seeing working copy. These are nothing but the workstation of individual developer or DevOps person, whatever team you consider, because we are considering as DevOps team, so individual DevOps person. Okay, this is a working copy. Each individual person, each individual developer or DevOps person will be working here. Okay, so how they work, they connect to the remote server, get the files from remote, make changes and put it back. Okay, technically these terms were called as check-in and check-out. Checkout means downloading the file and check-in means adding a new files to the remote. This is checkout. Technically, like just understand in layman terms, it's like downloading the file and uploading the file back to remote server. Technically, they are called as checkout and check-in. Checkout means downloading, check-in means uploading, means putting the file back to remote. Okay, so yeah, this is how they work. They connect to the remote server, get the changes to the local computer, make their changes and put them back. That's all. That's a simple architecture of centralized version control system. But it has got certain drawbacks. The main drawback is if this, okay, for to work with this kind of architecture, you always need network connections. Isn't it? Every person is connected to the remote server. Means, yes, network connection should be there to connect to the remote. For some reasons, let's say network got disconnected, entire work will be halted. You have to wait till the connection resumed, right? That's a one drawback. Another major drawback is suppose this central server or the remote server is crashed or gone for some reasons. Okay, something happened to this. There is no chances of recovery because it works like a single source of truth. All the project work is kept only on one place here. If this is lost, that's all, right? So these are the drawbacks of centralized version control systems. So to overcome these drawbacks, we have got distributed version control systems. Let's talk about the architecture of distributed version control system. But before going to that, let me tell you SVN, TFS, right? All this comes under central version control systems. There are many version control systems, right? You might have heard about SVN, TFS. All this comes under centralized version control systems. Any questions in this architecture? So if that is clear, let's talk about the distributed version control system. So here in distributed, yes, you also have again a remote server or central server, whatever you call it. All the project work is kept here. And this is the workstation of each individual developer. If you notice here, this is the workstation of each individual collaborator, right? This is the workstation of second person and so on. So if you notice here, every person is having another repository. This is called local repository. Means in distributed version control systems, there are two repositories, the remote repository and the central repository. Okay, sorry, remote repository and the local repository. Local repository is nothing but a copy of remote. Means every person will get a copy of remote repository into their local computer. And again, they don't work on local repository directly. Rather, they work on another directory called working directory or working copy. It's nothing but another directory or another folder. That's all. Right? So yeah, local repository, and they'll be working on a working directory. They work on some other directory called working directory, make the changes here, put those changes back to local. From local, they'll push to remote. Means to put the changes remote, it's like a two steps from working directory to local, from local to remote. That's how every person works. Okay, and majority of the work happens in local. Only once all the complete work is done, we'll push those changes to remote, right? So this is how distributed version control systems work. So yeah, what about network connectivity here? Yes, you need network connectivity to push and pull, isn't it? Here you need to push whenever you want to push. Push means, okay, you made some changes, you want to put to remote, then you need network connectivity. Similarly, if you want to create a copy to local, copy from remote and create a local, you need a network. Otherwise, to work within the local repositories, you don't need network connectivity, right? No network connections are required, no network connectivity is required to work on local, right? So yeah, means even though network connections are disconnected, you can still continue working. Entire work is not halted. Okay, that's a main difference between centralized and local, centralized version control system and distributed. Even though network connections are not there, you can still continue your work. Entire work is not halted. Once network resumes, you can push your changes, right? So that's how it overcomes the problem of network connectivity. Also, like I said, majority of the times, most of the times, we work on local repositories. Okay, once complete work is done, then we push to remote, isn't it? So because we are majority of the times we are working on local, means it's just in our local system, it is definitely faster than centralized version control systems. And the second thing is, even though the central server is crashed or lost or gone for some reasons, chances of recovery are more. Okay, because every collaborator is having a copy of the repository, right? Copy of remote repository which is local. So chance of recovery are also more. That's how it overcomes the drawbacks of centralized version control systems, and distributed version control system is the one which modern DevOps projects prefer. And yeah, what is meant by push? How do you push? How do you pull? All of them will be learning. A lot of hands-on will do on this architecture. Yes, we'll be talking about distributed version control system. Git falls under this distributed version control system. Git, fossils, Mercury, all this comes under distributed version control systems. Is this architecture clear? Any questions?
One question.
One question.
Yes, please.
Here,
Let's say I'm on
Huh?
let's say
currently I'm
working
working
on
on
working
working topic.
Your voice is not clear. Can you please come
Hello?
again?
Hello?
Yes.
Yeah, let's say
Yeah,
I'm
let's
working
say I'm
on
working on
You are working on?
local topic.
local.
Okay, local repository. You are
Yeah,
breaking
it's
down. Your voice is breaking. You are working on local repository or local? Who is asking the question? Okay. Yes, Amit. Please post your query. Yeah, this is a architecture of distributed version control system like Git, Fossils, Mercurial, all this comes under distributed architecture. Now we shall talk about Git. Yeah, and also why we are choosing it, why not others? Like I already said, yeah, distributed version control systems are preferred, and particularly Git is preferred because it has, because of its great branching strategies, branching feature, and many other features in Git. Git is mostly preferred, majority of the projects. See the graph from the Google Trend reports. This is a graph from 2020. You can also check the latest graph in Google. Okay, Git when compared with other tools like SVN, TFS, Fossils, Git is clearly the winner in the category. The blue one is the Git. Do you see that? So if you learn, if you master Git, yes, you have more job openings, you have more job perspectives. Yeah. So now that we understood the architecture of distributed version control system in general, let's talk about the architecture of Git in particular. Okay, let's see here. Okay, meanwhile, there is a question from Amit. I'm working on working directory. Okay, connection from remote gets disconnected. Now local have latest changes after replication between local and working directory. At this stages, how things will work. I mean, the latest changes are not on remote, they are on local repository. Yes, Amit, you are correct. We don't have local changes here. Yeah, see, suppose you are making changes here on the working directory. Okay, you are making changes here. So meanwhile, you don't have network connectivity. Yeah, obviously you might have pulled this. Let's say you have pulled this today at 9 a.m. you have pulled, right? And here this repository, many other collaborators, because many other people have connected to this. So many others have made the changes here by 10 a.m. But you have pulled this at 9 o'clock. And here you are making changes at 11 a.m. Now you try to push your changes to remote. Means, yeah, first you push your changes, which you made at 11 o'clock here. And from here you have to change. But here so many others made changes meanwhile, right? Between 9 to 11, so many others made changes here. So how do you push? Yeah, yes, how to push this, what happens now, how is remote repository in sync with local repository? If it is not sync, what happens? We'll be learning that. Okay, all of them comes under the hands-on. Here we cannot learn it theoretically. We'll do hands-on and learn all those scenarios. Okay, until then please wait. Now, yeah, come to Git architecture. Let's understand Git architecture. See, we have already learned distributed architecture in general. Now, let's look into this architecture in particular. See, this is a local repository. Okay, and yeah, like I said, there'll be two repositories, local and remote. And local means, yeah, this is on my own workstation. So, yeah, like I said, yes, we have got a copy from remote and created this local repository. Okay, we have created this local repository. Then there is another directory called working directory where we make some changes. Okay, so from working directory, we push those changes to staging area. What is the staging area? See, imagine working directory is some folder. If you are a Windows person, consider it as a folder or a directory. We call it as a directory in Linux. So this is one directory where actually we make changes, push them to local repository. Local repository is another directory which is a copy which is created by copying from remote. So, okay, you make changes in working directory. After you make changes from working directory, it's not that you directly push your changes to local. No, this doesn't work. Then what you should do? After making changes in working directory, you have to push them to staging area. What is meant by staging area? Staging area is nothing but a it is also called as index area. It's nothing but a virtual layer. It's not a folder. It's not a directory. You cannot see on your system. It's just a virtual layer. Okay, but whenever you make changes in your working directory, you have to put them in staging area. from staging area, you have to push them to local. That's how it works. Okay, you cannot directly from working directory to local. This doesn't work. This doesn't work. That's how the architecture of Git is. Then what is the importance of staging area? Why should we place it in a staging area? Isn't it? What is its importance? It works like a preview or else pre-check before your changes goes to local. Also, it helps you to have a better control on what changes are going to local. Means, let me give you a simple example. When you start hands-on, we'll be working on these components a lot to get a better understanding. Let me tell you a simple example. Suppose you have 10 files in this working directory. Out of them, I just want to place only 5 files into local, because whatever in your local, they only go to remote. Means whatever you want to put in remote, those changes we have to place in local. So only 5 files. So this staging area will help you control this. Means whatever changes I want to place in local, only those changes I'll place in staging area, only those 5 files. Means it works like a preview or else a pre-check, or else it helps you to have a better control on what changes are going to your local. Right? So that is how this staging area works. So how it happens: first make changes in our working directory, move your changes to staging area, then move your changes to local, from local to remote. It's like a 3 steps before your changes reaches remote. And let me tell you one more thing, I forgot saying this. Yeah, see, until you push your changes remote, until you place your changes to changes on remote, no one else can see them. Got it. Means there are multiple people working. Suppose you are making changes in working directory or local repository. They are confined only for yourself. Only once you push your changes, place your changes remote, others can see them. Got it? So it's like a 3 steps before your changes goes to remote. Okay, from working directory to staging area, from staging area to local, from local to remote. Right? What are commit, what is add, what is push, we'll learn those commands, but this is the concept. This is called Git tree. Am I clear? Any questions? So yeah, this is how you place your changes to remote. Now, okay, let me talk about something else here. Another interesting point. See here. Here we were talking about working directory, local repository, right? So working directory, local repository, or directories, I said, right? But like, what are these? See, let me tell you, this working directory and this local repository is one and the same. It's the same folder, isn't it? Then why are you saying 2 directories, working directory and local repository? Yes, these are the same directory. Physically, it's one and the same. Same directory. Logically, they are different. How come it's physically same and logically different? Means imagine this is all one single directory. Imagine they are overlapping one about the other. Sometimes you call it as a working directory. Sometimes you call it as a local repository. How is that? How is that possible? How can you say call sometimes working directory, sometimes local repository? Let me explain you. See, it's one and the same. There are not 2 directories, only one and the same directory. Then how come you say working directory? See, logically they are different, meaning suppose you just created a file here, you made some file here. Oh, give me a minute. Okay, you just created some file here or just made some file here and left it, that's all. Then we call it as, or we say it's in a working directory. Okay, after creating the file, if you add this file, then it is said to be in the staging area. Suppose after creating, after adding, you also did git commit. Git commit means it goes to local. Then we say the same file is in the local repository. But physically, where is the folder throughout? That box is your working directory or local repository, one and the same. Am I making sense? Understood this, everyone? See, I'm repeating. Working directory, local repository is one and the same. Physically, it's the same directory, but logically, it's different. Means don't consider them like two directories, just overlap one on the above, one on the other, right? So it's a one and the same directory. But then how do you say it's working directory? See, suppose you have just created a file and left it there, kept it there. That's all. You didn't do anything. You just created a file. Okay, then you call it, okay, the file is in working directory. After that, if you run the command git add that file name, then you say, okay, the file is in the staging area. Then when you commit when you run the command git commit, whatever in the staging area, okay, because the file is there in the staging area now, it goes to local. Then we say, yes, the file is in the local repository. Understood now how it is the same directory? And Amit, that's nothing but only once you push your changes to remote, other developers can see them. Okay, if you don't push those changes to remote, you just kept them in local. Only you can see those changes. Others cannot see your changes which are present in local repository. Only once you push to remote. Remote means it was shared by multiple people. All of them can see them. See, I'm repeating again. If the changes are in local repository, only you can see those changes. In the previous page, in the previous screen, see here, every person is having their own local repository. So if the changes are in your own local repository, only you can see them, right? Only once you push to remote, other people can see your changes, what changes you made. Your changes will be available to others only once you push the changes to remote. Am I clear? Got it, all of you? Understood? Any confusions? And working directory local repository, I'm repeating again, it's the same folder. Okay, see, or else I'll make it more simple for you. Okay, this is a folder. Okay, let's say this is a working directory or local repository. It's the same. Okay, working directory, local repository is one and the same. If you just go here, just simply create a file, means okay, I just created a file. Now tell me whether you call it as in a working directory or local repository. Working directory, that's all. After this, if I run the command git add, how to run the command, I'll tell you. So if you run this command git add this file name, then what do you say? Where is the file then? Staging area. But still physically it's in the same folder. Okay, the same folder can be called as working directory or local repository depending on the context of the file. After that, if you run git commit, you can say the file is in the local repository. Got it clear now? It should be clear for each and every one of you. There should be no confusions. Am I clear? All right. So that's a main thing you have to see. Once we are done with this architecture, we shall go to the lab. We shall talk about, we shall see how these folders are, what is, why, when it is called as. We'll see all of this practically in few minutes. Okay, first let us understand concept. Let's understand theoretically. We'll go to the hands-on in few minutes. So yes, this is what it does. And another important thing, let me tell you. How do you create local repository first of all? Right, okay, the directory, how do you create? You can create it in two ways. One is two scenarios, two use cases. Let's suppose, okay, you joined a team in between, like let's say it's a 2-year-old project. You joined the project today as a Devops person. Already there is a local repository, already a lot of project work is there. You have to copy it and create a local repository. Means copy from remote and create a local repository. That's one use case. Second thing is, let's say, okay, you join the team, it's a new team. There is no remote work. Okay, you have to develop the project work. There's no remote repository. There's no remote repository initially, right, in the beginning. So yes, you have to manually create an empty local repository, develop the code base so every person will do the same, and you push to remote and make a remote repository, right? So those are the two use cases. First, we shall start with this. Means assume it's a completely new project. Okay, we are a new team. So we will create a local repository manually, an empty one. Develop like I did today. Okay, I have created a folder, kept a file there, right? Similarly, we'll create a folder. We'll create means that's nothing but local repository. How to make a local repository? We'll see. Then put the files there. Add it to staging area. Push to place it into local and then push to remote, right? So first scenario also we'll take up. First we'll begin with the second use case, assuming it's a new project. Got it right? Everyone understood this? So yes, this is the GitHub. Now that we understood the architecture of Git, let's go with the hands-on. Good to go. Any more questions? Should I repeat anything? All right, so now let's go and install Git and start working with it. Before that, let me tell you, Git works on multiple operating systems. You can use Git on Windows, Linux, Mac, and so on. So first we'll be working with Git on our local machine, means on our laptop. It may be a Mac system or it may be a Windows system, anything is fine. Okay, Linux systems also it works the same. Only the installation part differs. Okay, the commands, the concepts differ on any, concepts are same on any operating system. So we shall do it in our local machine, our laptop. So first let us install Git. All these installation steps, okay, all the commands, all the architectural diagrams, everything is available on the Google Drive like I have shown you yesterday. Okay, once you register, you can get access to all this documentation. Okay, now let us install Git. Just go to Google and type in Git download. Okay, don't save the links. Anyway, I'll share you the link from where you can download, but this is the approach because the links, the references may be changing. Don't save the link and use it. See the approach how to get the documentation, official documentation or official links. Go to Google and type in Git download. You will see here something like gitsem.com, the official Git documentation. Click this. Okay, here you have all the downloads. Do you see that? Like I said, you can install Git on Mac, Windows or Linux. We'll see both Windows and Linux. Only like I said, installation steps differ. Okay, for now we don't need to go to Linux systems. We'll go to Linux a little later. Then we'll also use Git on Linux. Now let's install in our laptop. So just go to Windows, click on Windows. So you will see all the steps how to do it. You can just download the exe depending on your operating system, whether it is 32-bit or 64-bit. Download the exe. It's just an executable. Okay, installing Git on Windows is very simple. Download this executable, run the executable. You know that, right? Downloading the exe and run the exe. Then a wizard opens. You have to just click on next and continue throughout. I have already installed it on my laptop, but let me show you. You have every step in detail in the documentation. When you are doing hands-on, okay, follow this documentation and do it. If you are stuck up anywhere, here it is. See, okay, you have this complete Git folder, Git commands, Git installation steps, additional references, the architectural diagrams which I have used, everything is there. The same is with any tool, okay, as we go back. So go to Git folder and yeah, Git installation on Windows. You have all the screenshots of what I'm explaining. Go to this Git SCM. Okay, download this, go to this Windows, screenshots, every screenshot is available here. Download this executable, run a wizard opens, see, hit on next and just continue. Okay, because I have already done that, it doesn't work for me again installing. So you can do it from your end, just clicking on next. Can you all do this from your end? Just keep on hitting next, that's all, nothing else you have to do. So installation will be done. Okay, once Git is installed, go to your start menu and just give git bash. Whenever you install Git, you will have this git bash installed. Enter, open this. This is a bash terminal where you can run git commands. Okay, so now, yeah, you can go to some folder. I mean, you can now let's create a local repository. Just now we were talking about some, one second. Yeah, we were talking about this. How do you create local repository? Assume it's a new project. Okay, create a local repository, an empty local repository manually, work on it. Okay, then push to remote. So let us take up the second scenario or second use case. So this is the command line. Okay, before going and creating a local repository, let me tell you something. Okay, there is a question from participants. Sometimes we need to add the environment variables. Environment variables you need to add if you are using something like Maven and all. For Git, you don't need to add any environment variable. Here you don't need it. Just install and launch the Git bash. That will do. Okay, so this provides some bash environment to run Git commands. Okay, yeah, here if we are preferring command line. What is meant by command line? You run the commands from this command line interface. This is called CLI, command line interface. Okay, here you can create folders, anything from the command line. In Windows, how do you create a folder? You just double click and you create a folder from the UI, right? This is called GUI, graphical user interface. Windows has got graphical user interface. So if you want, you can create a folder this way. Let's say git demo folder. Okay, then go to this folder, create a files and all. That's how you can do. Or else you can also do the same, creating folders, any operations, any navigations, all the file system operations can be done from command line or as well. Because in real time, most of the times for DevOps particularly, we'll be working on Linux systems. Majority of the Linux systems has only CLI. You don't have GUI, isn't it? Like in Windows, you have GUI. Linux systems doesn't have GUI. You have to do everything from the CLI only, command line interface only. So just get practice, just get used to it. Okay, meaning instead of creating folders, everything from the GUI, use CLI. How to do it? We'll be learning small commands. Okay, just I want to go to this folder, copy the address. If you want to go to that folder, CD means change directory, that path. See, I am into that folder. PWD means present working directory. These are actually Linux commands. Okay, because like I said, this git bash provides you some Linux environment. So you can run the commands here. So just get used to work this way because CLI is more preferable. CLI is very faster than GUI. If you want to manage multiple files, if you want to work quickly, CLI is preferable. So even though you have GUI for your practice, you can use CLI on Windows as well like this. So it will show you where are you. Okay, in which folder are you? Present working directory is here. So yes, I'm into git demo folder. Now I want to make this git demo as a local repository. It's a normal folder now, right? I want to make it as a local repository. Git is already installed in our system, right? We have installed Git. If you want, you can confirm by running git version command. Git is installed. Git is installed on your system, but which project Git has to version control? Isn't it? Which directory Git has to version control? So go to the directory, whichever Git has to version control, or go to the folder wherever you want to keep your program files. See, this is the folder here. I want to put my configuration files, and this is what I want to make a local repository. Means manually create an empty local repository. but it's an empty folder. How do you make an empty local repository? Run a command called git init. Git init means initialize git, start git. See, initialize empty git repository means created empty git repository in this path in git demo. Means in git demo it has created a folder called .git. Open the folder and see here. Physically from the GUI you can see like this if you are more used to Windows, or else if you want to learn it on Linux method also, you can do ls-a. ls-a will show all the hidden files. .git is a hidden folder. Hidden files and folders can be seen with ls-a. List all the hidden files. You can see .git means yes, whichever folder is having .git is nothing but a local repository. So local repository or working directory is created. Am I making sense? I have created a folder called git demo. Then I want to put all my program files here, all my configuration files here. I want git to version control, git to track whatever present in this directory. So what I did, I have run the command git init in this folder. So .git folder is created, means yes, this git demo is nothing but local repository or working directory. Actually, we call it as a local repository. When you create a file and it's not staged, then we say it's a working directory. Is this much clear for everyone? Any confusions? How to create a folder using the command. So, okay, we have created a folder git demo from the GUI, right? If you want to create a folder on your desktop, just cd ... means, see, if this is your folder, if you want to go back, okay, this is how you go back, right? But how do you go back from the command line? Cd ... one level up. See, you are on the desktop. Now here, if you want to create a directory, make dir, another small command, make dir, mkdir. Let's say folder name is new folder. Okay, or else you check here. On the desktop, there should be something like new. This one I have created, right? So that's how. See, there are all the Linux commands we'll be learning separately. Here only I'm showing you a very little bit of basic Linux commands. Okay. If you want to go to any folder, cd git demo. So yes, I'm back in my git demo folder. If you want to go from GUI, this is how you can. Clear everyone till this part? Anything should I repeat? Any point you missed? All right. So yes, okay, git local repository is created. Let's create some files here. Okay, and let's manage them with git. Okay, so right click, and how do you create a file? This is how you create any files, right? New file and all from the GUI. How do you create from the command line? There are many ways you can create from the command line. First one is touch file1.txt. See, I'm creating a text file. If you are from the development background, you may create any Java files, C program files, C# files, Perl scripting files, whatever you want. Or else you want to create any config files, CFG files, anything is fine, because Git can manage any kind of file. I'm creating simply text files because here our interest is not to learn any coding or any configuration scripts now. First, we are learning to manage the files. So create some simple text files will do. We'll apply them to our Terraform config files, Kubernetes files as we progress. So first learn managing the files. So create a file with a touch command. It is created. ls will show the files and folders in that directory it was showing. If you want to make it clear, check from the GUI also. See, do you see that? File 1 is created, right? So that's how you create. Okay, file is created. So is it version controlled by Git? By the way, let me ask you, where is this file one? Of course, physically we know where it is. I'm asking, where is this file with respect to Git? Logically, where is this file one now?
Local repository.
Where is this file one? Logically, I have just created a file. Just created a file and kept it. So where is this file? Physically, it's in the Git demo folder. Logically, where is this file? You have just created a file, means where is it? It is
Local
in the
repository.
working directory. It is in the working directory. If you remember some time back we discussed, you just created a file and left it, means it's in the working directory. Once you run git add, it's set to be in the staging area, isn't it? Always keep this architectural diagram in your mind. Always keep this architectural diagram in your mind. Okay, where is the file now? I just created a file. Where is this file? Answer with respect to this diagram. It's in the working directory. So, okay, fine. But let's say I don't know. Okay, I'm new to Git. I don't know where is it. You can understand where is it by running the command git status. See, it's tell you untracked file. Means Git know there is a file, but Git could not track it. Okay, Git knows there is a file, but it cannot track it because it's asking. It is untracked. To track it, add it. It is asking us to add. It's not yet added. Means where is this file now? Definitely it's in the working directory. It is asking me to add to staging area. Okay, now what I'll do? Git add file name. Now tell me, where is this file? I want answers from each and every one of you.
Staging area.
Staging area. If you check Git status, it says changes to be committed. Okay, it says changes to be committed. Means where is it? It is not at a local repository. It's in the staging area. Changes to be committed. Okay, what should I do now? Git commit -m flag is mandatory, like a message, like a comments, okay, about something about your file. Let's say first file created. Okay, done. Now where is the file? Can you tell me?
Local repository.
Physically it's in the git demo folder, but logically where is it? It's in the local repository. When all of your changes are in local repository, it shows you like this. Okay, working tree is clean, means whatever changes you have added all of them to local. We didn't go to remote yet. We'll go to remote repositories tomorrow. Okay, before going to remote, we have lot many things to learn here. All right, okay, done. See, ls will show the files in the directory. It's a Linux command. Okay, it will show the files in that particular folder. Okay, git ls files will show you the files in the local repository. Understood? Shall we repeat it with another file so that the things should be more clear? Yeah. So yeah, let's create another file. How to create a file? First of all, from the CLI. From the GUI, you know. From the GUI also you can create. If you want, you can create from the GUI also. Go here, create a file. Yes, what is the command? Touch. Please learn the commands slowly. Okay, per day we'll be learning Linux commands per day, 5 commands like that. So that slowly you can get used to Linux commands. It's just another environment, that's all. Okay, so create the file. Now do ls. Yes, it's showing both the files. If you want to understand clearly, you can also check on the GUI. Okay, file is created. Now you can put some content there. Okay, I'm not adding any lines or any content. How to add the content to the files we'll see later. So file is created. ls shows the files in working directory. Git ls files. Why file2 is not shown under git ls files? Yeah, why file2 is not seen under git ls files?
Because we didn't add it.
Yes, we didn't add it to staging area and local. Now tell me, where is this file to?
Working
It
directory.
is in the working directory. You can also check status to confirm. See, untracked. Untracked means it's a new file. Git cannot track it until you add it. So what should I do now? Can you help me with the commands?
Git add
Git add, exactly.
file
File
2.
2. Now tell me, where is this file?
Staging area.
It is in the staging area. Changes to be committed, not yet committed. To be committed means you can see this diagram and tell me, where is it? To be committed means it is in the staging area. So yeah, after so now if I want to put them into the stage local repository, what should I do? Git
-m.
commit -m some commit message second file or whatever. Okay, now git status means git status command will tell you where is the file, what is the position, what is happening in the repository. Clean means whatever in your local repository were added, sorry, whatever in the working directory were added to local repository. Now you can see both of them under git ls files. That's all. See, initially there will be a lot of confusion over this kind of architecture, like moving the changes from working directory to local, but local to, I mean, working directory to staging and staging to local. If you learn these things carefully with clarity, you can enjoy working with Git. Git is such a tool. Initially, there will be some confusions for beginners. Okay, but learn with clarity, systematically, you can master Git. You can answer any kind of questions in Git, because here we'll be covering almost all the concepts we use in Git. Definitely you can answer 99% of the questions on Git. Okay, so just learn this carefully. Remember this architecture. Keep this architectural diagram in your mind. Always you have to think or work by following this architectural diagram. Okay. So yeah, and this is how you work with the CLI. Now let me show you another two interesting commands. Until now, whatever commands I have used, all of them will be shared. See, checking the version of Git, doing git init, creating a folder, all of these commands will be there in the Google Drive. Every day, do the hands-on. That is mandatory. After the class, watch the recording, do the hands-on. Only these commands. It's very easy to execute these commands and do the hands-on. It hardly takes you maybe 30 minutes. But don't pile up the things and plan to do it after some 10 days. It becomes difficult and it will be not possible. So, okay, fine. Yeah. Now let me show you another command. See, I told you like it maintains a log. Suppose I want to see what is happening and all. Whenever you are running a commit command, okay, we are running this commit command, right? This commit, I have committed twice. So these commit, whenever you run this commit command, whenever you commit the changes on the repository, it will generate a commit ID. Okay, commit ID is alphanumeric and it's unique. Okay, you can check all your commit history with the git log command. Git log. See, like I said, every commit will have the commit ID, unique one, alphanumeric, it's a hash code generated. See, and the commit message. Timestamp, do you see that? Like we discussed in the beginning, which person made the changes, at what time, on what lines, everything will be shown. See, author name, because I didn't write the author name, it was showing just some dummy lines. And Tuesday, August 9, 6:59, system timestamp, right? You can track this way. Let's say you just want to see a brief log, not a detailed log. Git log one line. Okay, means simple log, a brief log. See, only one line log you can see. See, you don't need the whole commit ID. You just need first 7 characters. So first 7 characters, commit message. Whatever you are giving in the M flag, you will see here. It's like a comment, because at a later point after 10 days, I want to see, okay, what did I do in this 858F8419? Okay, I have created first file. Means give some message, give some comment so that you can later on relate to the changes what you did. In real projects, you may be giving something like, okay, this is a change made for the revision or functional requirement 1, or else it was a change request change. What change is this related to? Some meaningful message, so that at a later point of time you can understand what changes you have done there, right? So that's a log command. It will show you the history of the commits. Also, yeah, you want to see what changes I have done in this commit. Git show the first 7 characters. See, it will show you here what changes we have done. Actually, I didn't add any lines there, right? They are empty files. So it was showing like this. But if you make any changes in the file, it will show you. If a line you have added means it will show you with a plus. If you deleted any lines in this commit means it will show you minus. We'll see adding the content later. So git show commit ID will show you the changes which you have done. So these are another 2 commands, log command and git show command. These are the simple or the basic commands. So, okay, till now we have created a file. What if you want to modify the file? Isn't it? It's not always that you keep on creating files. You may also have to modify the previous files, existing files, correct? So how do you do that? Just open the file, make some changes. So how can you do that from the CLI or from the GUI? GUI, you just open the file in any editor of your choice, put some lines here, that is all done. So how do you do here? From the CLI also, you have different editors. We'll learn the editors later, but there is another simple way to place some content. There is echo command in Linux. Echo command will just print whatever you write here. It's like a display print command. See, echo high means it will show you. Now, the same command output is high. That output I want to give as an input to file 2. Right, this double arrows are nothing but redirection arrows. This is again Linux. Whatever output of this will be placed in this file. Done. If you want to check what is the content of it, from the GUI, open, double click and see that. Or else you don't have GUI, right? I want to check the content of any file. Cat means read. That's another Linux command. See, don't worry about Linux. We'll be learning Linux separately. There were 2 classes. Again, we'll have all the Linux basics there separately. You may prefer GUI also here. If you don't want to learn Linux now, ignore them. Do everything from GUI. Only git commands run from this git bash. That is perfectly fine. Am I making sense? Or else if you want to practice them, this is how you can do. Cat will show you the contents present in any file. Okay, if you want to practice this Linux commands, this Linux stuff in your GUI, go to any folders, existing folders. Okay, you may have some files and folders there. So just go to that CD, go to that path, open those files using cat command, using echo command. You may place into some files. Just experiment, practice all those things. Okay. All right, coming back to our Git, yes, I have made some changes in file 2. So what should we do? What will Git status tell us? Where is this change? Where is this modification? See, changes not staged. Do you see that it was not telling you untracked file? Okay, but it was telling you changes not staged. File is already there in staging area, but the change you made is not in the staging area. Means, remember one thing, Git always works with respect to change. Your change may be creating a new file. Your change may be modifying a new file. Your change may be deleting a file, whatever it is. You have to put it in the working directory to staging to from staging to local. Here also same. Changes not staged means where are those changes? Where are the modifications? Added a line means it's a modification, right? So where is the modification now? Where are the modifications? Were they in the staging area, local repository, or working directory?
In the working directory.
Exactly. Not staged means it's in the working directory. So what you have to do? Git add file to. Now see the difference. To be committed, what should I do? Git commit -m file modifier, some message of your choice. Now git status. Yes, perfect. Right? Means I'm repeating again. Whether
I
you
have a
create.
question.
Tell
So
me.
when we modify the file also, we need to add the file and commit it.
Exactly. Git works with respect to the changes. Only with respect to changes. All the changes moves from working directory to staging area, from staging area to local repository. What is meant by change? Change means it might be creating a new file. It might be modifying a file. Okay, or else it might be deleting also. I'll show you delete operations tomorrow. Anything, okay, should be moved to staging area and local. But the difference is, if it is a new file, means if it is for the first time, what would be the status? When you run git status, it shows like untracked file. Untracked means new file. It's not at all there in the staging area and working directory. Okay, but if it is a modification, okay, but if you are modifying it, it will be showing like not staged. Do you see the difference? Have you noticed the difference? Learn these differences, learn Git thoroughly, perfectly, any tool. See, not staged. And if you remember earlier, it might have shown you untracked. Am I correct? Can you all recollect? But not now untracked. Untracked means new file, but the file is there already in staging area, but changes are not there. That's why it will show you like this. So don't get confused between untracked and unstaged changes. That is the difference. Okay, that could be another important interview question. What is the difference between unstaged? When do you see message like unstaged and untracked? Got it, all of you?
Yes.
Or else there might be a question like, were untracked and unstaged changes both are same? No. If it is completely new file, if the file is not at all there in the staging area, it will show you untracked. For new files, it will show you untracked. File is already added in staging, it's already in local. If you have modified it, it will show you like unstaged changes. Okay. So today we have understood navigating from working directory to staging area, from staging area to local repository. Practice this with multiple files. Also modifications, already existing file is there, modify and do it. Also practice small Linux commands like cd command, make dir command, touch command, cat command, very simple Linux basics. Okay, just practice them on your git bash. So that is all for today. Watch the recording, do the hands-on. Okay,
Yes.
and to continue from tomorrow, please register. 2 demo sessions, 2 introductory classes, like 2 demo sessions were completed. So if you want to continue further, you can reach me, register, get access to the Google Drive, I mean the documentation, and start doing your hands-on. Any more questions from your end?
Maybe every time I close Git and whenever I restart it, again, so every time I have to initialize it, right? Like Git init
No, every
initialize
time you don't initialize. Only once you initialize, only once you create local repository. Each time you don't need to create a local repository. You can directly navigate to your local repository and start working with it.
and even if I haven't issues git add or git init, even in that scenario as well, whenever I start Git, then I can see the file and directory that I have created, right?
Yes. Yep.
Okay. And version control doesn't make any sense unless git add followed by git commit hasn't been performed, correct?
Version control doesn't make any sense. I didn't get you.
Version control will come here only once git add as well as git commit has been done. Without these,
Git add you will be doing for every new file or every modification you will do git add, git commit. Git init is only once.
okay.
Git add, git commit you have to do always, right? We have done here multiple times. For each file, for each modification, you have to add and commit. Git add file 2, we have done it multiple times. Git add file 1. If you have 10 files, if you want to add all of them, git add dot. Dot means all the files will be added.
Okay.
And there is a question from another participant. Warning is there? No, what is that? Where is the warning?
Git add.
Not warning.
After
I guess
git
those
add, there is
messages.
a warning.
One by one, please.
Git
Yeah.
After git add, there is a lf lf is replaced by control lf or something. Warning is there.
That's not a warning, okay? It's just like the git verbose, git text, that's all.
What is that one?
That's
What
not
is
a
the
warning.
meaning?
That is showing that Git is adding the files to the staging area. It's not a warning or anything. It's a Git verbose. Git is doing some operations. You're seeing some text there. So that is all from my end. Okay, these are the very basics of Git. We shall proceed with the more advanced concepts like branching strategies, rebase, reset, all the advanced concepts. Okay, merging with conflicts, resolving the conflicts, how multiple people work together, how do you push to remote, pull from remote. See, we didn't go to remote yet. Okay, like I said, there are a lot many things to learn before we go to remote. So we shall take up from here tomorrow. So that's all from my end. Any more questions, let me know, or else we shall wind up here for today. All right, then. Thanks, everyone. Thank you for joining. See you all tomorrow. Bye, everyone.
Thank you.
Bye, Preeti. Have a nice day.